Morning, everybody. Gary Porter again. Found a potential problem with a motor design where the high voltage comes in and charges up these capacitors, and when you want to discharge a cap into the motor, you don't want to discharge all of them. You want individual charging paths for each cap. That buys you time to recover the capacitor back to the voltage that you need to run the motor. So high voltage comes in on this bus, and there's a NOR gate to the driver chip which controls the switch, which will disengage the high voltage coming in. Once the cap is charged up, the comparator says to the NOR gate, alright, turn off the switch. Or if the Hall effect comes in and says, I want to open the switch so I can fire the cap through this other Hall switch, controlled switch, into the motor coil. By doing this, you disconnect these other capacitors down the chain here. You can have as many as you want, are being charged by the high voltage, and this guy, when you discharge this into the motor coil set, this is no longer connected to the high voltage, so you don't suck the energy out of these other capacitors. And what you'll notice is there's going to be a amount of time these capacitor banks take to charge based on 5 tau, which is an RC. And the size of the caps determines how long it's going to take charged up, no matter, if you have to have that amount of time. So you're going to average out with a certain amount of energy that you can get based on your caps here, and also the back EMF coming back from the coils into the two halves of the system. This whole thing here is repeated. This is a positive portion. This whole thing is repeated for the negative portion. And the back EMF from the negative side, say you put in 100 volts positive from a cap into your motor coils, you're going to get back about 50 kV through diodes. That's going to be negative for the positive going in. That's going to go over to the negative side and recharge the cap, supposedly. But you're going to have a lot of losses through the diodes and whatever, and but that'll certainly help the high voltage recovering the cap back to its position. And so that's where we're headed with this. You got to have a NOR gate. The high signal here causes a low here, turning off the enable to the driver, and these are just a series of NE55 pulses which pulse the switch at a certain rate to charge up the cap from the high voltage capacitors from the Don Smith circuit. And that's how it works. And have a nice day.